In this video, we're going to talk about integration by parts. So let's start with, let's say you want to find the derivative of uv. And using the product rule, you'll get uv prime plus v u prime. Now what I'm going to do is I'm going to move uv prime to the other side and move d over dx, the derivative of uv, to the other side. So you get negative here, then plus v u prime. I want to get rid of this negative, so I'm going to multiply each term by negative. Get u v prime equals derivative of uv minus v u prime. Now what I'm going to do is I'm going to take the integral of each part. So you end up getting integral of u v prime is, what is the integral of derivative of uv? That's just uv. Minus integral of v u prime. Now if you polish this up, you'll get, it's the same thing as integral of u dv is uv minus integral of v du. And this is the formula when you do the integration by part. And we'll look at some examples. We're going to find the integral of x e to the x dx. Now notice, u sub doesn't work, and it's very difficult to find the antiderivative unless you use integration by parts. You usually use integration by parts when you have two functions that are connected by multiplication. So now we need to decide which one will be u and which one will be dv. So we have this acronym, LIPET. L is for natural log. I is for inverse trig. P is for polynomial. E is for exponential. T is for trig functions. So we're going to go this in order and see which one comes first. Well, we have x, which is a polynomial. We have e to the x, which is exponential. So here the polynomial comes first before exponential. So we're going to let u equal to x and dv equal to e to the x dx. This acronym will come very handy, so make sure you know how to use it. If u is x, what is du? That will be just dx, isn't it? Because derivative of x is 1. What about dv? What is a v? V is the integral of e to the x, which is just e to the x. So now let's plug it in. What do you have? You got uv, so integral of x e to the x dx will be uv, which is x e to the x, minus the integral of v du. What is our v? E to the x. And what is our du? Du is just dx. So you end up getting x e to the x minus integral of that is e to the x, and then don't forget to put plus c. So that will be your final answer. Notice, if you take the derivative of this, you'll end up getting x e to the x. Let's take a look at this example right here. You got x sine x dx. Okay, which one are we going to let u? And what about dv? We need to find what u is going to be and what dv is going to be. So again, well, let's go back to our acronym, LIPET. Do we have any natural logs? No. What about inverse trig? No. What about polynomial? We do. It's x. So u is going to be our x. And dv is therefore is going to be sine x dx. So what is du? Well, du over dx is 1. And moving dx to the other side, you just get 1 dx, which is dx. What about v? What's the antiderivative of that? It's going to be negative cosine x. So let's plug it in. It's going to be uv, which is going to be negative x cosine x minus integral of v du. So it's going to be negative cosine x dx. So negative negative becomes positive. And what's the integral of cosine x? That's sine x. So negative x cosine x plus sine x plus c, and that is your answer. Now what about integral of natural log of x dx? Well, let's follow the acronym. Do we have a natural log? We do. So you let u equal to natural log of x. Then automatically dv becomes just dx. What is our du? du is going to be 1 over x. Because derivative of natural log of x is 1 over x, and then dx. What about v? v is going to be just x. So let's plug it in. You're going to get uv, which is x, natural log of x, minus v du, x times 1 over x times dx. Well, here you got x and 1 over x, which becomes just 1. So you'll get x natural log of x minus integral of dx, which is, what's the derivative of dx? It's just x. And then plus c. Let's take a look at this example, e to the x cosine x dx. We don't have a natural log. We don't have inverse function. We don't have polynomial. We have exponential before trig. So u is going to be e to the x, and dv is going to be cosine x dx. What is du? E to the x dx. What is v? Sine x. So when you plug it in, you're going to get uv, which is e to the x sine x minus v du. So it's e to the x v du, e to the x sine x dx. Now, integral of that is not so simple, so it looks like we have to do it again. So we have to say u equal to e to the x, and du is e to the x dx, and dv is sine x dx. What is v? It's going to be negative cosine x. So this part, I'm only focusing on this part right now. That will be uv, which is negative e to the x cosine x minus the integral of v du. which is going to be negative. So negative times negative is positive. E to the x cosine x dx. Okay, now we already had that negative, so we're going to distribute the negative here. And we had this portion right here, e to the x sine x. So this whole thing is actually e to the x sine x. Negative times negative is positive, e to the x cosine x. And negative times positive is negative. That whole thing is equal to integral of e to the x cosine x dx. At this point, you might get frustrated and say, oh, we have to go through it again. But if you notice, these two are the same. So what we're going to do is I'm going to move this to the other side. So as a result, you're going to get 2 integral of e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine x. And then our goal is to solve for integral of this. So I just want to get rid of 2. So you end up getting integral of e to the x cosine x dx is e to the x sine x plus e to the x cosine x all over 2. Of course, the only thing that I forgot is whenever you take the integral, indefinite integral, you need to have a plus c at the end. So don't forget to put plus c.